Zero to Code Hero Perspective, episode 3.5, Data Types and Variables. Let's go! So, imagine you're going to visit your friend and you have a box. And you take this box and you just swing everything that's on your desk, on your table, counters, bookshelves, wherever, and you throw it all in this box, tape it up, and you're like, let's go. So, you go to your friend's house and you tell him, here you go, man. And he's like, hey, man, what's in the box? And you're like, I don't know. That doesn't help him very much because he's like, well, I have too much junk. I don't want to take in extra stuff. Or maybe I'm just going to toss it out because I don't know what's in there. Or maybe I just, don't trust the guy. I don't want to be pranked and, something pop out when I open it. It's important to know what's in our containers, and it's important to label them as so. So imagine this here. For example, we have x equals 5, y equals 10, c equals 35, and u equals 60. And we're talking about naming conventions right here. So let's say you take a role and they're going to have you work on this project, and the person in charge tells you, hey man, I sent you the data. You're gonna have to make calls to members that are over a certain age. With that age limit, you're gonna have to do no more than this many calls. I know it should say something about how long the calls cannot exceed, and it also has the price that our product now is being charged for. So you're just gonna give them a call, let them know how much it is, and just make sure you don't call them too much today, because it's illegal to go over that call limit. Cool, thanks, man. I'll email you the figures, and do your stuff. You're great, thanks. So you open up the file and you see this crap here, and you're like, what is this? So it's illegal for me to call so many times, and I can't be over the call limit. Like, what am I gonna do with this? This does nothing for me. This will happen if maybe you're just putting placeholders and stuff, and then you're gonna come back later and you're gonna be like, whoa, where did I pull this data from? What is this doing? What is this function using? I don't understand. Maybe I need to start from scratch, or maybe I need some more clarification. That can be the difference to this. So we can have max calls 5 for the day. We can have a call time limit of 10. We can have the age of the members that we're going to be calling, and we have the new price. Key name, I just put this on here because I'll touch base on that here in a second, but now you can make your calls for the day they're not answering. You called 5 times, no more. But this other member, he's 36 years old, you got a hold of him, your call time limit, you finished the call in 9 minutes, and you made sure that he understood about the new price change, and he was happy. Maybe it went down, maybe it went up, but maybe he's happy the price went up. This works hella better than what we had before, because what we had before, you don't know what those numbers are. I don't know what they are, and whoever gets that information next is not going to know what to do with them either. So that's why it's important that our variables are assigned properly with their names. That's not even covering our data types. So let's go back. What did I do? Oh, let me delete that. So let's say we have age equals 25, and then we have name equals Bob. Let's add the extra B. That looks fun. And then we have a bool expression. We'll say is broken. Is broken equals true. Not try. E-R-U-P. Okay. So we have age, we have name, and we have is broken. Oh, but somebody forgot to say, I want some pie too. 3.14 worth of the pie. 31.4. 3.14. So I want a slice of pie. I just want exactly 3.14% of that pie right there. So data types. Python is smart. Python is very smart. It'll know what you're entering based on what you entered, literally. Like, I can't make it any more simple than that. Like, age equals 25. Python automatically knows that this is an int. Python automatically knows that this is a float. Python knows that this here is a string. And Python knows that this is a boolean. This is important because I obviously cannot do print Bob, or whoops, my bad, name plus I. So if I try running that, let's go ahead and see, we get this. This is a type error, which is an exception for what we did. And it's saying that we can only concatenate strings to strings. It's very straightforward when you're reading it sometimes. It's saying not float. It's like, don't do it, bro. Don't do it. So we can only add string plus a string. So, okay, that makes sense. Now, I know I said we can't do it, but if we wanted to, you can do it in a sense. Just depends on the application of what you're doing. Like, let's say you wanted to just combine the text together. We can put str. We can convert pi to a string. So str, we covered the pi with parentheses, and then we said at the beginning of the parentheses, this is the data type I want this to be. So if I run it now, we get Bob 3.14 because he is an Android now, and we have the technology to make him Bob 3.14. So you can do this in scenarios where that's relevant, but by itself, Python will not do it. It'll tell you straight up, we can't do that. Can I do age plus pi? Yeah, we can. We can definitely do age plus pi, because nothing tastes better than a 28.14 year old pie that's been in the fridge for 28 years, if that fridge even still works. So yeah, you can do that. But let's say you don't want the decimal, or maybe you do need the decimal and you need it longer, like more precise. There's ways you can go about that. But for this demonstration, let's go back to our code. We're gonna cover that, and we're gonna say that we only want the whole number of age plus pi. So we're gonna do our program, we're gonna run it, and now we have 28. So 28-year-old pie in the fridge with frostbite, or whatever happens with a 28-year-old pie in the freezer or refrigerator, is better than that 0.14 extra that was on there. So there's different ways that you can handle integers, whole numbers, or decimals, floating point numbers. It's all relevant to what your end game is with your program. So we're going to clear that. So why does it matter? Because, I mean, obviously we know numbers can add, multiply, any kind of arithmetic really. And strings, we can join them, like concatenate, or we can slice them, which we'll talk about later. Booleans answer the burning question that we always demand in our life. We want yes or no answers. We want to have that, not the maybe. We want to know for sure, is this a yes or is this a no? So with the Boolean, we get true or false. Is this broken? True. That means it is broken. Is it false? It is not broken. So if we were to print is broken, we would get true, because is broken is true. But let's say we had a statement where, okay, this product will only ship if it is not broken. So we want to make sure that the function only runs, if it's not. So we put a check somewhere along the way to make sure that, we're seeing what's happening. So we could say print not is broken. And we can see that, when we run it, made it small. Go back. So we can see that it's false. So maybe there's scenarios where you'll want to flip the response of whatever our Boolean expression is, or maybe just in general, let's say a menu, while a choice is not this, display this. So there's different ways that a Boolean expression can be used. So that's why, numbers are important, strings are important, Booleans are important, because we want to do math, we want to do different methods that change the text, and we also want to use our Boolean expressions to answer the yes or no when we're doing logical, we're doing conditional statements, working logically in our program. As well as, just because Boolean is true or false doesn't mean it can't be used in different ways. So remember what we did before? We're going to go ahead and take is broken, put it in parentheses, and I want to see the integer of is broken. So I'm going to go ahead and run that, and I get a 1. So 1 is on, O is off. Does that sound familiar? Binary. So zeros, ones, on, off. So think of a Boolean expression also as, is it on? Is it off? Does this fire if it's on? Does it fire if it's off? So forth. So there's different ways to use all of these, in different aspects. As well as with our text, like let's say Bob, we can put name, and we'll cover this in another perspective where we can go into a deep dive on strings in general, but this is something that you'll use too. Either you're validating data with dot upper, or maybe you just want to scream at the top of your lungs. So we're gonna go ahead and close that, open that, and now we see Bob is all in caps. So variables, reusable containers, think of them that way. They're location in memory that has a name assigned to them. And the data types are what Python uses. It decides how to treat what's inside those containers. Understanding this, you've already unlocked like the foundation of Python, because Python is going to use all the data that you give it and then some, and make things work based on what you're giving it. So always remember the golden rule: garbage in, garbage out. If you give it bad data, give it bad naming conventions, you're gonna get bad end products. So take your time with your naming conventions. It all works out in the end. That's the foundation for what you're gonna be using when you're programming and so forth. So I hope you like what we discussed today. If you're watching right now, make sure you hit subscribe, hit the plus, or just subscribe, and I will continue to deliver content like this for you, because my goal is to make it to where you feel comfortable with your programming, with your code. And if you have any questions for me, leave me a comment, message me directly. I'll get back to you, definitely. But yeah, until next time, class dismissed.